Hello students, today's topic is the integration by parts. Shown on our screen is the integration by parts formula. The integral of u dv equals to uv minus the integral of v du. The integration by parts is useful when we want to find the antiderivative of products involving logarithmic and exponential functions. Let's start with our examples and apply the integration by parts formula. Starting with example 1, we want to find the indefinite integral of 5x e to the 3x dx. We notice that our product involves an exponential function, and we want to use the integration by parts formula. To apply the integration by parts formula, starting with the left side of the formula, the integral of u dv, we want to decide which part is going to be u and which part is going to be dv in our example. I like to choose u in a way that du is simplified. In this example, I want u to be 5x and dv to be e to the 3x dx. Now rewriting this here, we will have u equals to 5x and dv equals to e to the 3x dx. Now du dx equals to 5. We want du. We multiply both sides of the equation by dx, and we will have du equal to 5 dx. Here we want v, and v is the antiderivative of e to the 3x, which is e to the 3x over 3. Now, when I was learning this topic, I remember drawing arrows to help me memorize the integration by parts formula. I would draw an arrow from u to v to help me memorize the first term in the formula, which is u times v, and an arrow from v to du to help me memorize the second term in the formula that involves v du. This is not a necessary step, but I just wanted to share with you. Now, to find the indefinite integral, we will start with what we are given, and what we are given is the indefinite integral of 5x e to the 3x dx. Applying the integration by parts formula, the first term is u times v. U is 5x, v is e to the 3x over 3. So this is going to be 5/3 x e to the 3x minus the integral of v du. V is e to the 3x over 3, and du is 5 dx. So this is going to be the indefinite integral of e to the 3x over 3 times 5 dx equals, this is equal. Now we'll bring down the first term, 5/3 x e to the 3x minus, applying the constant multiple rule of antiderivatives to e to the 3x over 3 times 5, we will have 5/3 times the antiderivative of e to the 3x, which is e to the 3x over 3. We want to simplify the second term, which this is going to be equal. We'll bring down the first term, 5/3 x e to the 3x minus 5 e to the 3x over 9. We don't want to forget that we have an indefinite integral, and we don't want to forget about our constant, which is plus the constant c. We're done with this example. Let's do another example. Starting with example 2, we want to find the indefinite integral of 4x squared ln of x dx. We notice that the product involves a natural log function, and we want to apply the integration by parts formula. To apply the integration by parts formula, we want to decide which part is u and which part is dv. I want to let u equals to ln of x. In this case, du will be simplified, so u equals to ln of x, and dv equals to 4x squared dx. du will equal to 1 over x dx, and v is equal, which is the antiderivative of 4x squared, will be 4/3 x cubed. We now want to find the indefinite integral using the integration by parts formula. We will start with what we are given, which is the indefinite integral of 4x squared ln of x dx. According to the formula, this is going to equal to u times v. U is ln of x, v is 4/3 x cubed. So the first term will be 4/3 x cubed ln of x minus the integral of v du. V is 4/3 x cubed. Du is 1 over x dx. So this is going to be the integral of 4/3 x cubed times 1 over x dx. We notice that the x will simplify, and we will have x squared. Now this is going to equal, we bring down the first term, 4/3 x cubed ln of x minus, now we want to apply the constant multiple rule of antiderivatives here. We will have minus 4/3. The antiderivative of x squared, so this is times, will be the antiderivative of x squared is x cubed over 3. And this is going to equal 4/3 x cubed ln of x minus 4 over 9 x cubed. Since we have an indefinite integral, we want to add the constant, so this is going to be plus the constant c. We are done. I hope this video was helpful.